Okay, so let's call this part 2. What do we do if we're dealing with some kind of a stretch or compression, some kind of vertical dilation? So the equation y equals 2 times the quantity x plus 3 squared minus 1. Well, we still start the same way. We want to find our center. We want to know what the middle is. So we have to think about the fact that this is really x minus negative 3. And in doing that, we're identifying the fact that our vertex is going to be at the point negative 3, negative 1. That means our axis of symmetry is going to be at x equals negative 3. So nothing changed so far. We'll plot that vertex, we'll plot that axis so that we have something to work around. Now, here's where we want to think a little more creatively to make it easier on ourselves. If we know that that 2 is identifying a vertical dilation by 2, well, then we need to identify what exactly is happening. Vertical dilation is about changes in vertical spacing. So if we think back to our parent curve, y equals x squared, where we've got 0, 0, 1, 1, negative 1, 1, and so on and so forth. The vertical spacing are these spaces here. These are the sections that are being affected most directly by that 2. Now, normally, as I move 1 unit away from the vertex, I go up 1 space. And as I move 2 units away, I go up 4 spaces. Because x squared is the defining characteristic of this graph. 1 squared is 1, 2 squared is 4. That's the gap that we're seeing. Well, a vertical dilation by 2 means that I need to take those spaces and multiply them 2 times what they were. So in the case of my new graph, I'm going to go to the right one, but up 2, because 2 times 1 gives me that new spacing. And as I go to the right 2 spaces, I will go up 8, because 2 times 4 gives me that new spacing. Now, mirroring these points over my axis of symmetry, right, 1 space away, so I go 1 space to the other side. 2 spaces away, I go 2 spaces to the other side, and I plot my smooth curve. Again, we should always finish by identifying what our domain and range are. Things change when we start moving around. Domain, free space, negative infinity to infinity. No matter how far left or how far right we go on that axis, we will find some piece of our curve. It might be well away from the axis, but we'll find it. Our range, again, we need to think about that minimum value. Our vertex is a minimum, the minimum value is negative 1. Our range then begins at negative 1 and goes up from there. So negative 1 to infinity.